Hello guys, we're going to finish this lesson off. Sorry I'm not here today, but I will be back tomorrow. So we were really almost done with this lesson actually. So you should have plenty of time to work on your assignments, talk to each other. You guys can still message me questions and I'll still respond. So if you're stuck on something, again, just shoot me a remind and I'll see what I can do. But where we got to on Friday was we had this situation out pulling with an angled force. And the important thing about this was, again, we're still talking about tension. Sorry, my dog. We're talking about tension. But when I have an angled tension like that, what ends up happening is, again, we ended up with an additional y component. Most of our problems we've had to work with, the only y component we've had is gravity. And so our normal force equaled gravity. Because again, the normal force is the surface's response to whatever weight it feels on it. We talked about how if I'm pulling up on an object, I'm decreasing the weight on the surface. Now, I'm not actually decreasing the weight of the object itself, so Fg doesn't change, but my normal force is changing. So what we did so far was you have to be careful. When you have other y components beside gravity, your normal force changes, and that happens a lot with tension questions. So what we talked about was how we knew the sum of all the vertical components. Here are all my vertical components. We knew that had to equal 0 because I'm moving side to side, right? There can't be any net force in the y direction if there's no motion in that direction. So we knew it had to be 0. And then here were all of my y components, keeping in mind that, again, they were pointing in different directions. We used this fact to figure out that the normal force had to then be 400, which again makes sense. On your note card, you want to have this memorized, or you need to understand it. The normal force is a reaction to gravity, but if I have upward direction y's, that's going to decrease my normal force. If I have downward direction y's, that's going to increase. So this is what's on your note card. It's best you understand why, rather than try to memorize that. So let's keep going from here. So the last two parts we had were to find the sum of the horizontal components and find the magnitude of the frictional force. Well, let's go back up to the question. Let's look at we have two horizontal components here. What are they? Well, we've got Ftx and we have force friction. Now, if we go back up to read the problem, it doesn't tell us actually anything about friction. The only reason why we know there's friction is because it's a carpet. It doesn't tell us mu, so there's not much we can do, except there is something very important here, bolded, that tell us something about my horizontal direction. We are pulling this at a constant speed. If it is a constant speed, and again, I'm pulling it in my horizontal direction, which is what I'm looking at right now. If it's a constant speed, what do I know then about the acceleration? My acceleration is 0, right? Constant speed means acceleration is 0. My speed's not changing. Well, if my acceleration is 0, what else is 0? My net force. Now, my net force in particular in the horizontal or x direction, I could say that's the h there for horizontal, is going to be 0. So let's go down here. It says find the sum of the horizontal components. Well, the sum is the F net, right? That's the definition of F net, is the sum of all the forces in that particular direction. Well, because we have a constant speed, it has to be 0, right? Now, go ahead and write out, please, actually, too, what is our F net in the horizontal direction in terms of the forces? We highlighted the two forces here. What are they? Well, I have Ftx pulling in one direction, and then we have the force of friction pulling in the other, and so I have to subtract them. So knowing these two things, then we can find the magnitude of the frictional force. If I have to pull so that I'm pulling with a net force of 0, we can find friction. So I want you to finish this off. We know the net force is 0. We need to know Ftx, and then we can find force friction. Take a minute, figure that out, please. Okay, well, Ftx means I needed to do some trig here. So we already found Fty, but Ftx was going to be 200 cosine. Make sure you use cosine. Cosine 30, which I think is like 173, but let me do a quick checky here. We got 200, go away, right? Go away. There we go. Cosine 30. Yeah, 173. Okay, I've done this before. 0.21, sure. Which is 173.21. That's a 3. Okay, so 173.21. Well, I mean, this tells me they have to be equal, so force friction is also 173.21. Now, I want you to notice that, again, these questions often, when we're talking about forces, often refer to the magnitude. So even though friction, technically, we'd want to call one negative as well as the other one is positive, you can just leave it as a positive number, right? The magnitude is just the number itself. If we cared about the direction, they would say direction, right? And then we'd add the positive or negative. Okay, so with that, this question, I'm going to give you a hint. There is a question like this on the homework. It's number 5, but it's not nearly as hard as this. The reason why this one is super hard is it's abstract. This is very much so an AP question. They don't tell you a number for the tension. They don't tell you a number for the mass. They tell you the angles right here, but it's tricky. Solve for T1 in terms of T2 and mg. So once again, I want you guys to remember that when you have a question like this, it says solve for T1 in terms of T2 and mg. Think for a second what your answer should look like. I should have something equal something. If it says solve for T1, that means I need to have T1 equals. And that also means the only variables I can use are these guys. Now I can use sine, I can use cosine, I can use whatever numbers I have. We have 35 and we got 55, right? But I can't have any other variables besides these ones. Now, again, as well, that when we say T2, that does not mean you can use T2x or T2y. It has to be just T2. And again, trig functions, numbers, or whatever. So this is going to be your final answer. You want to have T1 equals. Now let's start with this. It says the stoplight is in equilibrium. Now, we've talked about this way back when about what equilibrium means. So it says if the stoplight is in equilibrium, what must be true? Equilibrium means there is no net force in either, or I should say any, direction. So this is my hint for you, and this is what you're going to use to attack number 5 in the homework, which is not as hard as this. What we know is that my net force in the x equals 0, and my net force in the y equals 0. I'm going to give you one more little hint here that you're going to want to redraw this. Sorry. With the tensions. mg is the weight. You should know mg is the force of gravity. Pulling down. And then we have these tensions pulling up. So you want to be careful about the directions for these two tensions. I recommend you draw them separately. Make sure you understand the directions for your x's and y's. Okay, but this is your hint here. If you're not sure on number 5, again, you can message me, or tomorrow at the beginning of class, we'll probably go through number 5. Once you're done with this, you are working on the L6 assignment. If you didn't turn in the lab, you can finish that up as well. I promise you guys I'll be back tomorrow.